Are you experiencing problems with your Zigbee network with devices suddenly going offline for no reason, sensors that are slow to respond, or lights that just don't turn on at all? Well, if that all sounds familiar, then you're not alone. And in this video, I'll tell you why you're having these problems and show you the steps you can take to fix them so that you can have a better smart home. Hey everyone, my name's Simon and welcome to Bite of Geek, a channel that's all about home assistant and smart home technology. So in this video, I want to talk about the problems you might encounter with your Zigbee network and devices, why this happens and how you can fix it so that you end up with a responsive and stable Zigbee mesh network for your smart home. These issues that can affect its performance broadly fall into three different categories, those being interference, problems with the mesh network, and the just downright obscure things, and each of these categories can cover several different problems in themselves. So the first issue you may well encounter is also the most common one, and that is if you're using a USB Zigbee dongle and you have it directly plugged straight into the USB 3 port, so that's the blue one if you didn't know, on your Raspberry Pi, your mini PC or your Nook, then you'll almost certainly be experiencing interference from that port. Intel produced a white paper on this exact issue several years ago, detailing the impact this can have, and it can be a significant increase in interference, which could potentially cause weaker devices to have issues communicating with the dongle. It's even been noted that having something like an external drive plugged into a USB 3 port next to the dongle has a similar effect. What you'll experience here will vary depending on your Zigbee network, but you'll almost certainly experience a flaky network with devices not responding or responding slowly. All is not lost, however, and there's a simple and cheap fix to this problem, and that's to use a shielded USB 2 extension cable to move the dongle away from the USB 3 port. Ideally, you want a cable between 50 centimeters and 2 meters in length so that it takes the dongle outside of the area of interference. Making this change could easily improve your Zigbee mesh from a flaky network to something that is now rock solid. Next up, and if you're using Wi-Fi and Zigbee networks in your smart home, then you may be experiencing interference from your Wi-Fi network. While Zigbee and Wi-Fi are two different methods of communication, they do, however, share the same frequency bands. A lot of this comes down to how modern Wi-Fi networks use their channels on the 2.4 gigahertz band to improve the link speeds for Wi-Fi clients. Zigbee uses 16 channels from 11 to 26, and most Zigbee networks will be configured as the default channel of 11. Now, older, slower Wi-Fi routers that would normally use the 20 megahertz Wi-Fi channel would roughly overlap 4 or 5 of those Zigbee channels depending on which Wi-Fi channel you pick. However, newer routers with a 40 megahertz Wi-Fi channel now overlap 8 or 9 Zigbee channels at once, which is a lot of the channels that Zigbee uses. This can have a massive effect on your Zigbee network. It can reduce the range, devices can drop, and the network can just become flaky in general. Fixing this can be as simple as changing a setting in your router, but you might also want to change your Zigbee channel as well, especially if you have other Wi-Fi networks crowding the space. So in your router settings, you want to look for something like channel width, and you want to force 20 megahertz only on the 2.4 gigahertz radio. You should also consider moving your Wi-Fi to a different channel. Use something like Wi-Fi Analyzer or Wi-Fi Man on your mobile to show what networks are the closest to you and what channels they occupy. Finally, consider changing your Zigbee channel to channel 25. It sits just above Wi-Fi channel 11 and therefore has almost no overlap. There is one caveat to doing this though, and that is, unfortunately, in many setups, you will have to repair all of your devices once you've done it. It's very much a one-time pain for long-term gain in this regard though. However, making these changes should improve things considerably, and it's probably one of the first things that you should consider doing. Now, Zigbee is a mesh network, and without truly understanding what that means, it's easy enough to think you can just buy a whole bunch of devices and throw them onto the network and hope that your smart home works perfectly. It's important that when you're buying Zigbee devices, you understand what their capabilities are and how they might affect your mesh network. First, we have what are known as end devices, and most likely it will be battery powered devices that you'll find here. So things like sensors and buttons. Although there are some other devices like light bulbs and relay switches that, depending on the brand, are also end devices. Where end devices are battery powered, they're generally super low power and sleep most of the time to conserve battery life. And because of this, they can't route any traffic onwards in the mesh network. When they're mains powered end devices, then this is almost always a design choice by the manufacturer. Next, we have what are known as routers, and these will be things like smart plugs and sockets, smart light bulbs and switches, and even things like pet feeders can be routers. These devices are on all the time and enable you to connect multiple end devices and route their messages through the network, meaning that you don't have to have everything hanging off the main coordinator and therefore spreading the load across the network. A simple example here would be a dumb light switch that controls a smart light bulb, and connected to that bulb might be your door, temperature and motion sensors. However, as great as routers are, there is one big flaw with them, and that is that they always need power to continue to do that routing. As soon as that device loses power, then it stops doing any routing. The issue now is that those end devices no longer have a parent to route their information, so they start scanning for a new router to connect to. But if that bulb was the strongest connection for them in that part of the house, and now it's gone, then those end devices may well drop off the network if they can't find an alternative that is strong enough. And even if you turn the switch back on, that doesn't mean everything will suddenly heal itself and start working again. Devices may well show as being online, yet they may not respond. Your whole network can become unstable, and your battery devices could potentially shorten their life as they struggle with the network. The obvious solution to this is to replace the dumb switches with something that is powered. That could be a relay that sits in the back of the box, or it could be a Zigbee switch that you wire to the main supply. You could also go down the route of wiring the switch to supply power permanently and then covering the switch, or even cover the switch and then pop a Zigbee button panel on the top and use that to control the smart bulbs. All of these will help to ensure that those devices that route through that device continue to do so and that your network remains at its best. So as I mentioned earlier, some powered devices are not routers and therefore they don't enhance your mesh network at all. And depending on the device type, you're effectively wasting money putting those devices in your smart home when you could be buying something different that not only functions as intended, but also improves your network. Now, this isn't exclusive to this brand, but it is an example of one, and that is Singled, and their bulbs are specifically end devices. This was a specific design choice to do this, and they have no routing capability at all, and therefore, other than being smart, they add nothing further to your Zigbee network. It's not a huge problem if you've got a small number of these devices, but if you've got 20 or 30 of them, then it becomes an issue. You've effectively created a network with limited meshing capability, but more importantly, you could be overloading routers, or worse still, your coordinator. And it's this last point that's critical, as some cheaper coordinators may not have the capability to handle such large numbers of children, the result of which will be dropped packets and devices showing as unavailable as the coordinator struggles to deal with the high level of traffic. Seeing if you're affected is easy enough to check out. If you go into your Zigbee map in Zigbee to MQTT or ZHA, whichever one you're using, and if you look at your device type and it shows it as powered, but it says it's an end device and you've got a whole bunch of these, then they could well be causing you problems, especially if they're all going back to the same router or coordinator. Singular bulbs aren't bad bulbs. The design decision fixes one problem, but unfortunately, depending on how your network's configured, it introduces another. But fixing this is simple enough. Consider mixing in some IKEA Zigbee bulbs so that the singlet ones can route through them, or even add some smart plugs like Shelly and Sonoff, which will act as routers. Just make sure that you're repairing those bulbs to the new routers and spreading the load, and certainly avoid them all going back to the coordinator. Now, with the right devices and configuration, a Zigbee network can be very robust and perfect for your smart home. In normal operation, when an end device has a routing issue, then it will start scanning the network for a new parent, and usually within a few minutes the network will repair itself and the device continues to operate. This is part of the Zigbee standard and how it's meant to work. However, there are some devices on the market that don't follow this exactly, and this is generally down to a design decision that's been made, such as conserving battery life. In this case, these devices stay locked to a particular parent, and if that parent disappears, then they effectively go offline or become unavailable, even if there's a stronger router nearby. I've personally experienced this with some of my older Aqara Zigbee devices. It's simple enough to resolve. You just generally press the button on the device to wake them up, and within a couple of seconds they're back online. But it's a pain to have to do it, especially if you've got automations that use those devices. The newer Aqara Zigbee devices are less sticky in this regard, and they rejoin the mesh more often. So if you're buying those, then look out for the sensors with the T1 in the model name. But if you're like me and you have a bunch of the older devices, then you could try building your mesh with strong routers first, and then adding those sticky devices last so that they latch onto the routers, making sure that you've got a couple of routers within reach of your sensors. And if you enjoy this type of smart home content, then hit the like button and subscribe to the channel for more videos like this that I create every single week. But the next issue you might encounter will very much depend on the type and quantity of Zigbee devices you have in your network. Zigbee is a low latency network and is designed to send small packets of data like the state of a sensor across the mesh. That packet of information, though, doesn't just contain an on or an off, it also contains everything that the network requires to function correctly. Now, the issue arises when you have devices that are overly chatty or have badly written firmware, causing them to constantly report information when they don't really need to. The result of which can cause your network to get flooded with information and effectively start to back things up. Power monitoring plugs are a big culprit of this, as they constantly report the power information based on the load going through them. Some light bulbs that report their power consumption will do the same as well. I've even had an outdoor sensor that had badly written firmware that was constantly reporting temperatures when it only actually needed to do that as a minimum every 30 minutes. When you multiply this information out across all those device types in your network, add on the information reported by all your good devices, you'll soon start to realize that your network is having to handle a lot of work just to keep up with what's being asked of it. What you'll end up with is delays in devices responding, groups of lights turning on one after the other, and the more devices you add to the network, the worse this will get. To help fix this, you have several options, the first of which is quite simple, and that is that you can change the stupidly low default reporting settings to something a little more realistic. So in Zigbee to MQTT, if I go into one of my power monitoring plugs, for example, you can see in the reporting that this is set to report every 5 seconds if the value changes by these values. Now, obviously, if you need that frequency of information, then you may well want to leave this as is. But if you've left them on the default, then it's certainly worth considering whether you need all of them to be reporting quite so frequently. You could also choose to shift those devices that report power consumption to talk directly to the coordinator, effectively freeing the rest of the network up to do its job. This, however, could be a bit of a pain if you're dealing with a lot of devices, as you'll need to repair those devices to do this. Finally, you could add more devices that act as routers to help spread the traffic load in the network. Just simple plugs and bulbs will often make a difference here. But I'm curious though, what other things have you done to try and improve your Zigbee network? Let me know in the comments below. Now, the next issue in my list is overheating, and I'm sure some of you are well aware that when your computer is overheating, that it starts to throttle the performance of the CPU, which in turn causes everything to start to run a lot slower. Well, the same thing can happen with smart devices, especially those that we stick into enclosed spaces like socket outlets. These tiny little modules are often put into tight spaces that have no ventilation, and whilst they may work fine during the colder months, as soon as things start to warm up, then they start to struggle as the onboard temperatures start to increase. When this happens, they start to throttle themselves to prevent issues. However, the result is that you don't get the experience you wanted, with increased errors and devices starting to become unavailable. Often it's the dimmer modules that are the culprit here, as well as the cheap devices that many will rush to buy first without realizing the impact they'll have on the network. And if you look at the LQI values for these types of devices, you may see it fluctuate or the device become more unstable as it gets hotter. There are several things that you can do to help with this though. Everything from putting the modules into a deeper or separate space if you can. For dimmers, you might want to consider switching to a different module type or limiting its rating, or locating the module in the ceiling rows if possible. And then there's the obvious one of bypassing the cheap devices and buying something with a proper thermal design. Now, if you've been using the same Zigbee dongle for a while, or maybe someone is giving you their old one, then the chances are that this dongle or coordinator will have a much smaller amount of RAM on board than some of the latest models available. As your Zigbee network grows, the more routers and end devices you connect back to the coordinator, the more it has to keep track of, and therefore the more RAM it needs to do so. With older models such as the Texas Instruments CC2531, they have a small amount of RAM, and therefore whilst they can have a relatively large number of devices in the network, they are generally limited to a very small number of direct connections. Again, this then puts the emphasis on you now ensuring that you have sufficient router devices in place to ensure you have a stable network. Without this, you'll experience issues with devices joining your network, or even worse, randomly dropping off. But to check this, it's simple enough. In Zigbee to MQTT or ZHA, you can easily see via the network map how many devices are directly connected to the coordinator. And if you've got more than 15 or so devices directly connected to your CC2531 dongle and you're experiencing issues, then this is likely the cause of the problems. To resolve this though, consider upgrading your dongle to an EFR32 or CC2652 based device. They have more RAM and generally perform faster as well. You could also consider flashing it with another firmware version that might increase the limit, but you're still working with what is now considered to be outdated hardware. Now, the next one is something that sounds like it might be some old wives' tale, but this is indeed very true. That old microwave oven you have in your kitchen may well be causing your Zigbee network to be unstable every time you go to use it, especially if you have routers or your coordinator near it. The problem revolves around what might be leaking from the microwave. As these appliances get older, the door seals start to get a little worn and dirty, and therefore their effectiveness starts to degrade. Sure, they are still cooking the food, but because they operate in the 2.4 gigahertz band, that leakage can start to impact wireless networks operating in that same space. What you'll see is device LQI start to drop, devices stop responding, and some devices starting to become unavailable. And it's simple enough to see if this might be affecting you. You can either turn off the microwave for a while and see if your network improves, or you can turn it on for a couple of minutes and observe what happens to your devices. The obvious fix here is to replace your aging microwave with a newer model, but if that's something you'd rather not do, then if possible, try to relocate the microwave or your Zigbee coordinator and router. And finally, you can try moving your Zigbee coordinator to a different channel like 25 or 26. And yes, it might still be impacted, but it may well be less than what it currently is. And finally is the impact of your Zigbee signal experiencing multipath interference from reflective surfaces. Yes, if you have large mirrors in your house or stainless steel fridges or other shiny appliances and your coordinator is near those, then they can be impacting the performance. It's a very technical topic to go into detail in this video, but it can genuinely introduce random dropouts that in some cases can be introduced when reflective doors are open or closed, making it difficult to diagnose the problem. How you fix this can be simple enough. Try moving your coordinator away from these types of things or angle the antenna in a slightly different direction. And of course, consider adding more routers to your network to help the mesh use those when required. So there you go. Hopefully that gives you some ideas as to how you can help improve the quality of your Zigbee network to make it more robust and responsive, giving you a better overall smart home experience. I hope you enjoyed the video, and if you did, then don't forget to like and subscribe to the channel so that you don't miss more smart home content like this. But as always, thanks for watching, and I'll see you in the next video. Bye for now.